Hello, my name is James Norman, and I am the Engineering Manager from Storage Made Easy. In this video, I'm going to explain how we can optimize our object storage to get the best for the media and entertainment industry. Some of the concepts I'll be covering in this video will be related to the media and entertainment industry, but also do have relevance to other industries that deal with big data. One of the common themes we see when we speak to our customers in the media and entertainment industry is an increased number of data streams that they are having to process. Whether that's from TV output in 4K, 8K, Ultra HD, whether that's the numerous number of cameras that they are using to film a particular TV episode, normally 5, 6, 7 or 8 cameras per episode, whether that's data coming in from video surveillance cameras, recording real-time footage, whether that's footage coming in from mobile devices, from end users and customers, whether that's footage coming out from consoles, like esports for example, and whether that's virtual reality data as well. There's a vast increase in the number of data feeds the media and entertainment firms are having to deal with. Also, these days, not only are they getting an increased number of feeds, the volume of those feeds is also getting bigger and bigger, and it's presenting lots of challenges. Let's look at an example of a chat show on TV. Typically this will be recorded in UHD, and they'll be using about 8-bit RGB at about 24 frames per second. With this combination, we're looking at about 33 gigabytes per minute worth of raw footage. Now if we multiply that by 60, we get to the total size for a single episode of this chat show. So we're looking at roughly 1.6 terabytes for the full stream from the TV show. Now it's typical for these TV shows also to be recorded by five or more cameras. So let's multiply that by 5 and we're suddenly looking at roughly 10 terabytes worth of footage per episode. This actually doesn't really come anywhere near the actual amount of data that the media firms are having to handle, because this footage will then be transcoded into different formats, perhaps localized into different languages as well, and so this number just keeps on growing, and this is just covering one single episode. So media and entertainment businesses need storage systems that can not only handle the capacity for this amount of footage, but can also be used inside of their existing workflows. The customers that we speak to will typically have two types of storage. They might have some local file or block-based storage, and they'll also have some object storage. They'll have some file and block storage because it provides them with very fast local access to the data that they have on that storage. But that storage has an upper limit in terms of the amount of data that it can store, and also it can be very expensive to scale. And that's why they look to object storage. People use object storage because it can handle very large volumes of data, terabytes, petabytes, and exabytes worth of footage that can be put onto the object storage. One of the neat things about object storage as well is that the performance there can scale as the cluster scales and helps to eliminate hotspots. It's perfect for unstructured data, like footage from TV shows, for example. It's also very performant, and there's lots of tools built into the protocols for the object storage that can help increase the performance that the clients using the object storage need. For example, DLOs, multi-part uploads, and range reads. There's also great cost savings potentially to be had there. There's built-in DR, and there's also geo deployment for the object storage as well. But this just covers why object storage is great. But what do firms in the media and entertainment industry, and also in general the big data industry, need when they're evaluating their types of storage platforms? There's really a couple of things that they need here. First, they need storage that needs to scale and always be available. They don't want that storage going down at the crucial point, and they potentially want off-site backups. This is something that object storage can handle very well. They need to pull data down or up in the quickest possible way. Again, as we touched on in the previous slide, the object storage platforms often have things built in like multi-part uploads and DLOs and range reads. They need to be able to secure the data and enforce security policies. While this one's kind of incomplete from an object storage point of view, perhaps they can put things like server-side encryption so the objects land encrypted at rest on the storage, but they can't necessarily define security policies on the objects that are there. They need to be able to share the data with internal and external parties. So if they're working with an external post-production house, for example, they need to be able to distribute those large files with people outside of the business. And typically they don't want to make the object storage available to those people because they can't put the fine-grained access control on the data stored inside. They need to be able to access the storage in crucial workflows. For example, when they're editing the movies, or when they're in their DAMs or the MAMs, or whether they're in genome labs or research institutes. They need to have the end user access to the storage as well. They also need to have ease of use as well. If the object storage is to be adopted inside of the organization, it needs to be easy to use for both technical and non-technical users as well. So clearly there's some things here that the object storage can do very well, but there's also some things that it can't do so well at, and we need to look at ways of addressing this. That is where the Storage Made Easy Enterprise File Fabric comes in. The Storage Made Easy Enterprise File Fabric is a platform that you can deploy on-premise that can sit alongside your storage. It provides connectors into 60 or more different storage types. For example, object storage platforms that are, for example, S3 compatible or Swift compatible. Into file systems as well, like StoreNext perhaps. And also into typical cloud-based services as well, like Dropbox, Google Drive, Amazon Cloud Drive, and many more. So it provides connector interfaces for more than 60 different storage platforms. And it brings those all back into one place, giving the users and the IT management a single pane of glass view into the storage. Once the organization has deployed the file fabric, it gives benefits for both the organization and the users. For the organization, it gives them benefits such as being able to put security controls on their storage, ensure they're being compliant with any compliance legislations that they have to be compliant with. It gives them auditing capabilities, tracking, control, integration with identity providers such as Active Directory, LDAP, and SAML. For the users inside the organization, it gives them benefits such as ease of access to their storage, no matter where it is. It gives them a single pane of glass to go and access their storage, whether that's object storage, file storage, or cloud storage. It gives them a really nice set of collaboration tools that they can work with their colleagues, collaborate on different projects with one another. And it also gives them a really great set of productivity tools and tools at their fingertips to really make their work easier. So what we're going to do in the next couple of slides is go through why using the file fabric alongside the object storage can help address some of those requirements that we identified before. So first of all, we are integrated into every point of access where the users need us. We have web-based access, which means they can access from any major web browsers without any plugins required. We have desktop access that can present itself as a network share or as a standalone application. We provide that for Mac, Windows, and Linux. We provide dedicated applications for iOS and Android. And we also provide legacy protocol gateways that support FTP, SFTP, FTPS, and WebDAV. So if they have legacy applications, they can speak those protocols and the files can land on the object storage. All of this means that it works within your existing tool sets that you have. There's no need to re-architect the workflows or the tool sets that you have. What I'm going to show you next is how this actually looks from an end user's perspective on their Windows desktop. So here we have a simple scenario of us accessing maybe our object storage or our different types of storage straight from our network share on our local PC. So here on the left hand side you'll see that we have the cloud drive mounted, and you'll see that we can already see the different types of storage platforms we have, all as folders that we can now drill into. What I'm going to do is I'm going to open up this object storage at the bottom here and drill into each of the files and folders that we have in here. I can see a file called Big Buck Bunny, and I'm going to open it and start streaming it. You'll notice I didn't have to download, copy, or move that file to my desktop. I can open it straight from the drive. And now I can start to scrub through this video and see the contents of this video. That's as easy as it is from the desktop. Secondly, there's no more command line required. Users of object storage have often been very familiar with using the command line to both put objects into the object storage and also get objects out at the end as well. With the file fabric, there's no more need to use the command line because you want your object storage adopted by not only technical staff but also non-technical staff as well. So the really nice thing about the file fabric is that it presents the object storage as files and folders, as we just saw, so you can drill through each file and folder and access the objects in there. There's no more need to use the CLI. Data movement is also really important for big data use cases, and through the file fabric it's as simple as a drag and drop data movement. Storage Made Easy has spent a long time developing its MStream technology, and its MStream technology at its core is the transfer of a file or an object in multiple parallel streams between its source and its destination. It can do that between different cloud systems, so it can take that from perhaps a file-based system onto an object storage, or an object storage back to a file-based system, and those can be in different data centers, in different countries, in different times. And those can be in different data centers and different countries. It can also help with the acceleration of transfers between a client's desktop and the storage. It can also help accelerate the transfer from a storage system down to the end user's desktop as well. And it can transfer terabyte-sized objects without any problem and uses the standard protocols provided by the storage platforms to be able to move the data in a fast and efficient way. So for example, it uses DLOs, multiple uploads, and range reads behind the scenes, and doesn't write the data in any proprietary fashion. In this example, I'm going to show you how you can use the MStream Upload feature to take a file that's stored on our local hard drive and move it onto our object storage. Typically you might have used the command line to do that, but with the file fabric you can now just drag and drop that file into your object storage. So here we have an example of the Big Buck Bunny movie, and what we're going to do is we're going to drag this from our desktop and put it straight into our object storage. Now this is just from my local home connection, so the speed isn't fantastic, but it's minimizing the effect of latency across the network. This storage is also on the west coast of America, and I am based in London. As I mentioned before, it's not written in any proprietary fashion, so you can now, if you want to, use the command line to get this object, and the whole file would come back down again. In the next example, I'm going to show you how to use the MStream cross-cloud transfer functionality. In this case, I've got a situation where I have some files on object storage, and I want to take them across to our file-based storage. An example use case for this might be that you want to take some archive footage you have on your object storage and move it into the editing suite where the local file system is mounted there. As we touched on before, it's as simple as drag and drop. So in this case, we're going to take the 10 GB movie and we're just going to simply drag and drop it over to the file storage. That task has now been started to move that 10 GB file from our object storage over to our file storage. There's no need to sit around and watch this now. We could walk away, go make a cup of tea, come back the next day even and turn off our PC. This is all running on the server side, so there's no data traveling up and down between the client here. And as we can see, it's pretty much maxing out the data pipe in the data center there. Object previews are also really important for many end users inside of the organization as well. With object storage, there are no previews. If you want to see what's in a file, you have to download the full file. But with the Storage Made Easy file fabric, we can now give you previews of lots of different file formats. In the media and entertainment industry, we can preview movie files, we can also preview images if you like as well, and other formats. In the medical industry, we can preview DICOM files and also genome files. And we also offer a very broad range of generic previewers as well, for example Word, Excel, PowerPoint, and more. So the really nice thing is there's no need to download the entire objects now just to see a preview. Let's take a look at how that actually looks. So here we have the Big Buck Buddy, the file we just uploaded a minute ago. What we can do is we can go and select the file, pull out the information pane, and click play. This is now going to start streaming the video down rather than downloading the full file. And what we can now do is we can go and start scrubbing inside of the file to a particular point in time, see whether this is the video that we're after. Ah yes, this is the one. And now what we've been able to do is quickly preview the file, no need to download the full file, and we can quickly get to the files that we want to. Content distribution is also a common challenge we see in the market. When organizations are looking to share files between organizations or between users, what we often see is that they're using insecure file servers or cloud systems to transfer those files, such as insecure FTP servers. The problems with those platforms is that they can't track the access, they can't expire access to those files after a period of time, they can't individually protect the files, and they often share credentials between different companies as well. What we propose is they replace that with a secure file sharing platform like the File Fabric, where all access to files is logged, where they can do easy inbound and outbound sharing, so they can receive files and also send files in a secure fashion. They can also individually protect files using passwords, time-based expiries, and limits on access. And of course, as standard, they would get real-time reporting of access as well. For me, this is particularly nice because with the way that organizations currently do it, they're duplicating files onto other storage platforms, which is again time and money. Now with the File Fabric, they no longer need to do that. They can keep the file in situ where it belongs on the object storage, for example, and they can share the file from the object storage without actually giving them the receiver access keys or secret keys. They get a secure link where there can be passwords, timed expiries, and limits on access. Let's have a look at how this actually works. So here we want to share the Big Buck Bunny movie again. So what we do is we select the movie file, we go to the sharing dialog at the top of the screen here, and we can say share by URL. When we're setting this up, we can say put an expiration on it, for example 3 days. We can put a limit in terms of how many downloads can be made. And we're also going to set a password, so the person receiving this link must enter this password in order to access the file. So great, here we've generated a shared link, and now we can choose to send this by email if we want, or we can send it by SMS too. So now we have the link. Let's imagine we've sent this to our friend, and he's now going to access this file. So he's going to open the link. He needs to enter the password because the user who shared the link entered a password, and he can now download the file. So we haven't needed to replicate that file onto a different storage platform. Every time this person accesses this file, it's all logged. And of course, after a number of days, this file will no longer be available as well. One of the other really nice aspects as well of the File Fabric is that it's storage agnostic and it does nothing proprietary. It's storage agnostic from the point that we work with over 60 different clouds and the functionality is common across all of them. We also don't write data in any proprietary fashion. So what you put through the File Fabric is what you get out on the storage. We don't chunk the files in any special way. We don't convert the files into hieroglyphs. There's pretty much no vendor lock-in there from the file fabric point of view, and as we highlighted earlier, we use a lot of the underlying technology with the storage platforms like MPUs, DLOs, and range reads, and versioning to deliver a lot of our functionality as well. We do this from a point of view of reducing the vendor lock-in, but also from the point that we also support a hybrid access model where you can continue to use your storage directly, as well as accessing the storage through the file fabric too. There's also an intelligence piece that comes into the file fabric as well. So the file fabric itself can integrate into Google Vision, Amazon Media Services, Elemental, and more to come as well. And through those integrations, we're providing things like automatic tagging and classifications on files like your videos and images, for example, so it can help identify where Madonna is, for example, in your videos. It can handle things like automatic transcription of your videos. So if you have videos, we can get the scripts for those videos automatically. And all of this information and all of the information that it generates is searchable at your fingertips as well. So going back to the requirements that we had earlier, let's revisit them just to see where we are now. So the storage can still scale because we're relying on the object storage for that. Needing to pull data up and down in the quickest possible way. Well, we've seen that with the object storage. We could do that through the CLI before, but now we can do it in a much end-user intuitive way now as well. We now can put a tick against the need to secure the data and enforce security policies. We can now put a tick against the need to share the data with internal and external parties as well. We showed you some of the sharing functionality. We can also put a tick against the need to access the storage in crucial workflows, for example in DAMs and MAMs. We saw through that the examples from the desktop's point of view as well, and that all links into the ease of use as well. So thank you very much for watching our video today on how to optimize your object storage for media and entertainment. I hope you've enjoyed it and found it informative. If you'd like to find out more information about the Enterprise File Fabric, you can visit our website at storagemadeeasy.com. Feel free to contact me if you have any questions. My email is james@storagemadeeasy.com, or if you'd like to contact sales, they are at sales@storagemadeeasy.com, and they'd be more than happy to organize a free trial of our Enterprise File Fabric. Thank you.